Okay, flipping now to the back of your page. The top thing you need to fill in is the word noble. This was our warm-up today. The noble gases are here in group 18. So if you haven't already done so, please put a star above group 18 and make sure you label that your noble gases on your periodic table. It's a good idea to do that in your notes here too, just off to the side, put a star above group 18 and label them your noble gases. One way to think about the noble gases is that they're so fancy they don't want to bond with anything else, as if nobility is sort of above and doesn't want to mix with anything else below it. Maybe that's a silly analogy, but it sort of helps me remember that noble gases do not bond with anything else at all, ever. And the reason for that is that they already have full valence shells of electrons, and we're going to look at next what that means. So the next thing you need to fill in is, we're sort of going back and thinking about this hopefully in a more simple way. Going from left to right across a period, which is a horizontal row on your periodic table, each element has one more valence electron than the one before it, which should make sense because if I have one proton, then I have one electron, two protons, two electrons, three protons, three electrons, four protons, four electrons. So if it has one more proton, then it has one more electron. And the outermost, or valence electron, is increasing by one also. So if we think about an atom like hydrogen, which has just one proton, or an atom like helium, which has two protons, that's going to be the same as the number of electrons, right? So hydrogen has one electron, helium has two electrons. But this atom, lithium, has three total electrons, and you can see that the first two are sitting down at the front row. And the third electron has to sit at the second row. There's not a VIP seat left for it. So it's sitting at the second row by itself. So lithium has just one valence electron. That's important. It has only one electron that can be involved in chemical bonding. The next element on the periodic table is beryllium, which has an atomic number of 4. That tells us there's 4 protons, which means that there's 4 total electrons. The first two, of course, sit VIP, and then the next two are valence electrons. Our next element has 3 valence electrons, and our next element has 4 valence electrons. In a moment, I'm going to show you a shortcut for how to figure out how many valence electrons there are instead of putting them in and counting them every time. So now we're going to go back even further, and let's fill in a word we've been using a lot, or I've been using a lot. Electrons occur at certain energy levels, or electron shells. These rings of electrons are called shells, and the only ones that matter are the ones on the outside. Those are the valence electrons. Underneath that, we have even more review. We're going to back up and just think about this stuff in even a more basic way. The atomic number is the number of protons. That's the most important thing we see on the periodic table. And you see I've symbolized protons here by a lowercase p and a plus. You're going to see that in your homework and as well a lot moving forward from here. P plus stands for protons, and if protons are positive, they have to equal the number of negative electrons in a neutral atom. And then another thing we just looked at in the diagrams is that first VIP row only has 2 seats in it, or can only hold 2 electrons, and the next 2 shells can both hold up to 8. 8 is the magic number that we're going to be using most of the time when looking at chemical bonds. Our last 2 words that we need to fill in are going to be valence. You might want to put a big star or highlight this part because this is a big idea about everything we talked about in our notes today. Only valence electrons, the outermost ones, are involved in chemical bonding. And that atoms will lose, gain, so there's transfer, or share, which is covalent, electrons, symbolized by a lowercase e and a negative. It's going to be our symbol for electrons, so that they have a total of 8. If you happen to know which animal has 8 legs, of course it's the octopus. So the prefix octa means 8. A full octet is why the Noble gases do not bond with anything else at all, ever. They already have a stable full shell of 8 electrons.